So now that we know what a shell is, and we also know which shell we're going to be using, we probably ought to learn what a shell script is. Okay, well first we'll take a step backwards and talk about executable files. You can say that some of the files on any Unix system are deemed executable. We'll talk more about what executable means in a moment. All of these files can be thought of as programs. So we've got some of the files on a Unix system are programs. The rest of them, well, I guess they're data files. Files that are used by these programs. Now, of the programs, some of these are compiled from source code, such as C or COBOL or Pascal or something like that. The source code is written, the source code is then compiled, and you end up with an executable program that can then be run. The compilation process converts the source code in a human-readable format into the executable file in a machine code, machine-readable format. It is not really possible for a human to read and understand the machine code inside a binary executable file. Now, the other sort of program are the ones that are not compiled from source code. These are called scripts. These are, of course, fully humanly readable in that the files themselves contain only text. They contain the commands to be executed. Of all the programs in the world, there are two different types: scripts and binary executables. Now, we're still not down to what a shell script is yet. You can say that there are many different interpreters for scripts. Another way of saying that would be to say that scripts are written in many different languages. The interpreters include programs like awk, sed, and Perl. They also include the Bourne shell. The Bourne shell is the most popular interpreter of scripts in Unix. Another way of saying that would be to say that more scripts are written using the Bourne shell as the interpreter than any other script. Although, having said that, with the advent of web pages, Perl scripts are now becoming very, very popular in their uses in CGI. So let's look at a summary of what I'm trying to say here on the next page. Let's look at a diagram. Think of this circle as all of the Unix executables that are available. Now, a subset of those, you can say a subset are scripts, the rest of course being binary executables, and a subset of those are shell scripts, the rest being awk scripts or Perl scripts or sed scripts or something else. Let's now actually go and have a look at an actual Unix shell script. This window that I've pulled up on my screen here is actually a telnet session that I have used to connect to my internet service provider, which are known as ZIP. If you're a little unfamiliar with what telnet is a program that enables you to obtain a login prompt and thus a shell on another Unix system. It's actually possible to obtain a Windows-based telnet program, which is what I have here in front of you. The window you can see on the screen is actually the telnet program, and I've used that program to connect to another computer out there on the internet. The computer just happens to be my internet service provider, and it just happens to be running Linux, and my login shell also just happens to be Bash, the born-again shell. The rather complex prompt that you can see there, mvirtue, that's my username, at zipper_ii, that's supposed to stand for zipper2, that's the name of the computer, and the squiggle, the tilde, the little squiggle character you can see there, that represents my home directory. /course is telling me that I'm in the course subdirectory of my home directory. So now I can use that, of course, to enter programs. So I could say ls-l, and there are some files. As you can see, I have one subdirectory called log files, and I have 3 actual files, 2 of which are executable. One of those files, I'll open annotate logs. This is an example of a Unix shell script. Let's have a look at it. To have a look at it, I type in vi rotate logs, and here we are. Now, all these lines here that begin with a hash, I'll come back and tell you at a later time what those hash lines mean, but I'm going to ignore them just for the moment and say that the first actual command in this file is this one: cd into the following directory, into my home directory, into the course directory, and then into the log files subdirectory. So the first thing we do is we go in there. Then we remove a file called program.log.6, and then we do some renaming until finally we get down to the last line in the file, which says rename a file called programlog and call it programlog.1. Now this is a shell script. If you just ignore those initial 4 lines, you'll see that it's actually very, very simple. It's just a series of commands that you could actually type in yourself on the Unix shell command line, collected and put into a file. And when the script is run as a program, each of those commands is executed in turn, one after the other. You might even be able to guess what the program actually does. Well, it's simply used for keeping track of the last 6 or 7 versions of a file called program.log. If there is a file called program.log, it's renamed to program.log.1, and then if there was one of those, that's renamed to program.log.2, and so forth, all the way back to program.log.6. Then perhaps in the middle of the night some program runs and another version of program.log is created, and so we run the whole thing again the next day, removing the old .6 version and creating a new .1 version. Let's see if we can't run it and see what it does. Okay, so I'll quit out of this and I'll do an ls -l of the log files subdirectory, and we'll find there's just one file in there called program.log. So let's run the script. Let's just find out what it's called again. It's called rotate logs. Notice that I just have to type the actual name of the file by itself on the command line, and that will actually cause the script to be run. Now I get what appear to be a series of error messages. The first is coming from rm, the remove program, saying it can't remove that program because it's not there, and that's fair enough, I suppose. And then 5 error messages saying that 5 different files cannot be renamed, but there were actually 6 different rename commands in that script, so it seems that one of them has succeeded. Let's have a look in the log files directory again, and notice that the file that was in there called program.log has been renamed to program.log.1. Now I guess if we ran the rotate log script again, program.log.1 would be renamed to program.log.2, and so on. The script would be obviously expecting that a new file called program.log would have been created in that subdirectory. So this script that we've just had a look at is a candidate in the automation category of scripts. Remember I said there was automation, administration, and then CGI programming. This is simply automation. All of these commands could have been entered by the user. The 7 different commands in that file could have just been typed in manually whenever the user wanted to do a little rotation of the log files. However, not only is that time consuming to do all that typing, but the user could actually make a mistake. So the benefits of putting all those commands into a file are that you never have to type them all out longhand again, and that if you get it right the first time, you'll get it right every time. That's a tremendous benefit.